After the first problem of trusses that we have seen, where we have seen the method of joints as well as method of sections, let us go ahead with two more problems related to trusses where we are required to find forces in few members. Obviously, method of sections will be the useful method, but we will be even discussing the method of joints. Consider the very first problem. We are given a truss as shown in the figure with the dimensions, and we are required to find the forces in member DF and DE. So this particular force DF and DE, these two are to be found out. Now to solve this particular problem, we will be taking a section. So this is one force which is required to be found out, DF, and another is this. Now obviously the section should be drawn in such a way that it should be cutting only 3 members, and we will plan to have the section say in this manner. This is how the truss is to be cut. Obviously our earlier assumption is that all the forces, all the members are in compression. So the 3 forces which will get exposed, this first, this will be second, third. I am showing them on one side. Of course they are present on the other side also, and we are required to decide as whether we should be considering the left hand side or right hand side. In this case I will prefer to have the left hand side of this particular truss, and so we will say that pass the section plane, section, to cut the members, DF, DE and CE, DF, DE and CE, and consider left hand side. So let us redraw that part. We will be drawing only the left hand side of it, of that particular truss. And this is how it will be drawn, only the left hand side. The section is like this. There is a load of 30 kilonewtons at point A, a load of 20 kilonewtons at point B, this is point C, D. Of course this is force in DF, then this is force in DE, and this is force in CE. Now we are also required to locate the intersection. DF and DE are intersecting at point D. So we have got one intersection point. These two forces, DE and CE, are intersecting at one point which is point E, which is there on the truss also. And if we extend force DF and force CE, then they are going to meet at some point which does not belong to the truss, but it is some point which is outside. The distances are also known to us, as this distance is 1.2, even this distance is 1.2. This height is known, which is 0.9. So we can determine this angle theta, say theta 1, and there is going to be some angle which will be made by CE, let us call it as theta 2.